This chapter 1 teaches you how to depict an FX exposure by means of a simple graph, and how to explain and quantify the consequences of leaving the exposure unhedged. We begin by taking the simplest of all FX exposures, one that arises in the ordinary course of a company's international trade operations. Assume that a US company has exported computer software to a UK company when the spot sterling dollar exchange rate is 1.5. The exporter has invoiced the UK company for 10 million sterling, payable 12 months from today. But what matters to the US exporter is what this amount will represent in US dollars when it is paid. Specifically, while the sterling receivable would be worth $15 million if the spot rate remained unchanged, it could be worth substantially more if sterling were to strengthen, and substantially less if sterling were to weaken. Worksheet long GBP lists, over here in column B, values for sterling spot ranging from 1.3 to 1.7, and in column C the corresponding value in millions of US dollars of the receivable on its payment date. Please note that we have hidden rows 20 to 44 for the sake of space. Over on the right, we have the graph, and the upward sloping shape of this graph should not be at all surprising, since the exporter clearly benefits from a strengthening of sterling, indicated in our graph by a move towards the right. So over here towards the 172 point. And by the same token, a weakening sterling is indicated in our graph by a move towards the left, so over here towards the 128, where the value of the receivable diminishes. A good exposure diagram would presumably conclude by flagging the area of the graph that represents the undesirable outcome for the company. In this case, clearly the area towards the left, where the revenues in US dollars are diminishing, often done, as you see, by use of the smiley faces as we do here, as well as the desirable outcome represented by the area on the right. One final question regards the range of values to show for the x-axis variable on the exposure diagram. There is no unique answer to this question, but consistent with many measurements in risk management, an interval spanning 2 standard deviations up and down from the current level may be a reasonable one. To illustrate, suppose that the standard deviation, also sometimes known as the volatility of sterling dollar over the long term, has tended to be around 10% annually, which is just about the correct number, by the way. Our suggestion would be to show the range from 20% below the current spot of 1.5 to 20% above it. 2 standard deviations on each side. This means, of course, the range from 120 to 180, which is pretty close to what we had done earlier in the diagram. This way, you are showing the client scenarios that have some plausibility without going to absurd extremes and being accused of trying to scare the client into doing a deal under any circumstances. One important point to note is that the upward sloping shape of this graph would invert if the receivable were denominated in a currency that is quoted as the term currency versus the US dollar, such as the Swiss franc, the Canadian dollar, the Singapore dollar, or most emerging market currencies. If you are not familiar with the distinction between base and term currency, please review our module Foreign Exchange Introduction. Take the case of a receivable in Swiss francs. The spot rate for dollar Swiss as of mid-May 2009 stood around 110. Which of course under the normal quotation method would mean that 1 US dollar equals 110 Swiss francs. If the receivable from the software export were for 10 million Swiss francs instead of sterling, an increase in the spot rate over the next 6 months to, let's say, 1.3 would of course correspond to a weakening of the Swiss franc against the US dollar, and would thus reduce the value in US dollars of the receivable, turns out from 9.09 million to 7.69 million, and vice versa if the spot rate declined. More generally, we can write that the dollar value of the receivable is the face amount in the foreign currency multiplied by the spot when the face foreign currency is the base currency, whereas we would write dollar value of the receivable equals face amount in the foreign currency divided by the spot when this foreign currency is the term currency. Worksheet long CHF plots the graph illustrating this Swiss franc exposure under the receivable and confirms the accuracy of what we have said. We have once again the table here on the left and the graph immediately to its right. It is common in many presentations to show this graph as an inverted but straight line, although a moment of reflection should indicate that it is in fact not a straight line, but rather one that is quite convex, as you see here, and specifically what is called in math a hyperbola. The value of the receivable in US dollars is given by the formula 10 million divided by spot. So this graph would have the same overall shape as the more generic graph for y equals 1 over x, which is, of course, a hyperbola in mathematics. Using smiley faces once again, we can depict in a very simple way the desirable and undesirable outcomes for the company as the dollar Swiss franc spot rate changes from its current level. If now we take the case in which the US company has imported goods from Switzerland and is examining its exposure under what we call a payable for 10 million Swiss francs. We would recognize that this time it is the company's costs or expenses and not its revenues that we would plot on the y-axis of the graph, which would make the area that is highest the least desirable one, and the area that is lowest the most desirable one. The graph in worksheet short CHF confirms this and indicates clearly the undesirable area of the graph here on the left, and of course the desirable part of the graph over here on the right. Once again, smiley faces are available to assist the mentally challenged. Remember which direction is which. Finally, if our US company has imported goods from the UK and is once again examining its exposure under a payable but for 10 million sterling, we would recognize once again that this time it is the company's costs or expenses, not its revenues, that we would plot on the y-axis of the graph, which would again make the area that is highest the least desirable and the area that is lowest the most desirable. The graph in worksheet short GBP confirms this and indicates clearly the undesirable area over here towards the right this time, since sterling is the base currency against the US dollar. And one last time, our friends, Mr. and Mrs. Smiley Face, can assist your understanding if this all still seems to you a little harder than relativity theory or molecular biology. You might conclude this exercise by showing in tabular form the approximate probability of each scenario and its outcome on the company's financial performance, including the effect the unattractive scenarios would have on the company's key financial metrics, such as net income, EBIT, margin, or any number of other alternatives. If you decide to do this, however, you will have to make very clear what assumptions you have made and point out that many of these calculations are based on financial models that are known to be inaccurate to some degree and frequently evolving. Illustratively, and reverting to the case of the 10 million sterling receivable, assume the US company's income statement for 2008 showed net income before taxes of $10 million. You would first recall from your knowledge of a normal distribution that the area beyond one standard deviation on either side represents some 16% of the total area under the curve, and that the area beyond two standard deviations on either side represents some 2.3% of the total area under the curve. This enables you to summarize the outcomes of the scenarios depicted in your graph earlier using the following table. Dollar value of the sterling receivable 13.5 million if sterling has fallen to exactly 135, and 12 million if sterling has fallen to exactly 1.2. Dollar loss in value of that sterling receivable versus the current spot of 1.5, well, that's just the difference between the 15 million and this 13.5. So 1.5 million here and 3 million here. And finally, impact that these losses would have on net income before tax for 2008, clearly a 15% reduction in income relative to the 10 million shown in the title, and over here a 30% reduction. What are the principal assumptions we would advise mentioning here? These would be, first, that sterling dollar spot returns are quote-unquote normally distributed with an annual volatility of 10%. And second, that a weakening spot exchange rate would have no other impact on the company's financial performance. This completes our first chapter.